Imagine standing on a rocky world where the sky never looks the same twice. Some days with one dim red sun hanging low over the horizon, and other days with a second sun rising to paint the landscape in twin shadows and double sunsets. It feels like a scene from science fiction, perhaps a nod to the twin suns of Tatooine. Yet this is a real place about 190 light-years away, called Towai 2267, and astronomers have discovered something there that is rewriting the rules of how planets form. Towai 2267 is a compact binary, two cool red dwarf stars orbiting each other at only about 8 astronomical units, a region once believed too chaotic for Earth-sized planets to grow or survive. And yet, in this gravitational tug-of-war, NASA's TESS mission detected multiple rhythmic dips in starlight, revealing at least 2 confirmed Earth-sized planets with orbital periods of about 2.28 and 3.49 days, plus a third candidate, making this the first known binary system where Earth-sized planets transit both stars separately. This discovery is more than a headline. It directly challenges long-standing theories that planet formation in such systems should be nearly impossible. Classical models predict that the combined gravity of 2 closely orbiting stars would shred the protoplanetary disk, disrupting the gentle collisions and gradual accumulation needed to form rocky planets. But Towai 2267 exists. Its planets roughly Earth-sized, likely rocky, and locked into short, stable orbits around stars once assumed too disruptive to host them. One explanation is that the protoplanetary disk was massive and long-lived enough to withstand the double-star turbulence, allowing material to accumulate in narrow, stable rings. Another possibility is planetary migration. They may have formed farther out and slowly spiraled inward, shepherded by gravitational resonances that sculpted their final orbits. Whatever the pathway, the existence of these planets shows that nature is far more adaptable at building worlds than we once believed. If you stood on one of these planets, you might see one red dwarf frozen in the sky, its warm ember-like glow never setting if the world is tidally locked, while the second star might rise and set across the horizon in strange rhythms, producing seasons of double dawns or solitary sunsets. Though we do not yet know their masses or atmospheric compositions, their sizes place them squarely in the terrestrial category, and even though they orbit close to their stars, the stars are cool enough that the exact temperatures remain uncertain. These worlds sit inside regions once thought inhospitable, but without atmospheric data, we cannot say whether they are scorched, temperate, or veiled in thick heat redistributing clouds. Instruments like the James Webb Space Telescope may someday reveal traces of water vapor, carbon dioxide, or methane filtering through their atmospheres during transits. Beyond the beauty of double suns, the significance of Towai 2267 is statistical and philosophical. Binary stars are common, perhaps more common than single stars like our Sun, meaning this system forces us to widen the search for Earth-like worlds. If 3 Earth-sized planets can form and survive in a compact binary of 2 red dwarfs, then Earth-sized planets are likely far more abundant across the galaxy than early theories predicted. Each unexpected discovery forces scientists to revise models and challenge assumptions. TESS, built simply to watch nearby stars for tiny flickers, has revealed a galaxy full of worlds that defy expectations: hot Jupiters, warm super-Earths, mini-Neptunes, and now rocky planets in gravitationally complex binary systems. The next steps include measuring stellar wobbles via radial velocity, studying transit timing variations to detect gravitational interactions, and attempting atmospheric characterization with powerful telescopes. Whether these planets are scorched, frozen, or surprisingly mild, they have already taught us something profound. Planet formation thrives even in the most unlikely environments. They remind us that our solar system is not a universal template. It is just one example in a cosmos filled with strange architectures and gravitational experiments. TOI 2267 expands the boundaries of what is possible and invites us to imagine a universe where worlds emerge not only around single, steady stars, but also around pairs of dim red suns locked in an ancient celestial dance. And in that dance, 3 small planets quietly orbit, proving once again that the cosmos does not just challenge our theories, it challenges our imagination.